Roger, the apparent fine-tuning of the universe is one of the hottest and indeed most controversial topics in our intellectual life today. Among physicists, argue about it among each other, philosophers, theologians, and then philosophers, theologians, and physicists all together. I want to get your sense, first of all, about the legitimacy of the question in terms of, is the universe fine-tuned, particularly the initial condition?
Well, the universe is certainly fine-tuned in the sense that the initial state of the universe was extraordinarily special. Now, usually when people talk about this fine-tuning, they're talking about something quite different. They refer to the constants of nature, which could conceivably have quite different values. One of the most obvious ones is the relationship between the gravitational and electric force. Say, take the force between a proton and an electron and a hydrogen atom, and there's a number with about 40 zeros. But I'm not altogether convinced by these. I mean, it could well be that there is special fine-tuning in these numbers, which is necessary for life. It's certainly the case that if these numbers had different values, and sometimes not very different values, then life as we know it couldn't have happened. But that doesn't mean that some kind of life or some kind of consciousness, which is really what you need, because a conscious being in these anthropic arguments, you say, well, how could consciousness have arisen? That's the key point. And since we have such little understanding of what consciousness is and what's the necessary prerequisite for consciousness, okay, the argument is a genuine one, it's a genuine question, but it's so far from being able to be answered that I really see it's almost unusable in most circumstances. There are a few cases where I think it's usefully usable, but the trouble is we know so little about the circumstances which are necessary for life.
For other kinds of life.
Yeah, I mean, other kinds of life. Yes, our own kind, we know.
We know.
But that's all we know, and we're biased to thinking about it in those terms.
The fine-tuning is fine-tuning for our life, but that doesn't mean that other kinds of tunes can play other kinds of lives.
Exactly. There could be something completely different. And in any case, conscious or intelligent life is probably extremely rare. I mean, it's not all that well suited to it, you see. And in any case, it could be that it could have come about in completely different ways. Now, there's fine-tuning in the origin of the universe, which has to do with the second law of thermodynamics. It has to have been extraordinarily precise, and in fact, it has to have been at least as precise as 1 part in 10 to the power 123. Now, that's
an extraordinary number.
It's a ridiculous number, yes. That's right. And it's nothing like, people worry about the constants of nature. You see, you want to fix those constants. Okay, they're just a few numbers, 20 numbers maybe. Yeah. And those have got to be fixed to, I don't know, just a certain amount of precision. And that's nothing by comparison with this number. The precision that we see in the initial state of the universe completely dwarfs any of these other considerations. Now,
what does that really mean, though, that precision in the initial condition based on the second law?
Well, what it means is that the anthropic argument is useless for explaining it. I mean, in this context, it may mean all sorts of other things.
Yes.
But in this context, it's telling us that the anthropic argument is absolutely useless for telling us why that number is so precise, why the universe was so precise. I mean, if it was, that number is so, the precision is so incredibly enormous because you have to do it for the whole universe. If you just had to do it for our solar system or for our galaxy, the number would be ridiculously smaller. And that's all we need. We don't need the universe as it keeps on going and keeps on going, keeps on going, but it's there. We're given it. We don't need it for us. So the anthropic argument goes nowhere, absolutely nowhere close to explaining that. It has to be a completely different kind of explanation. Now, maybe the anthropic argument has something useful to say about the constants of nature, but it's so hard really to use it just because we don't have much understanding of what life is or what consciousness is.
But going back to the initial condition and the incredible specificity that the universe had to have, I mean, that's our universe.
Yeah.
I mean, that's the one if we're going to explain existence, which is we're here in this existence, that's the one we got, right?
That's right. Absolutely.
So we got to explain it.
Absolutely.
How do we do it?
I completely agree. But it's not the anthropic argument. That's what I'm saying.
Then what is it?
Well, I have various ideas about this. I mean, you can make a hypothesis of a certain kind, which is something I have put forward, referred to as the Weyl curvature hypothesis, which is saying that the space-time curvature in the initial stages of the universe has to have been of a very particular kind. But that's just a hypothesis. The usual view is that some form of quantum gravity, or whatever it is, has to explain why that comes out.
And that level of precision is so impossible to conceive of as from some random point of view. I mean, that's not something that you can achieve in a random fashion under any. I mean, in infinity you can do anything, obviously, but that's
it's no explanation. I mean, that's right. I mean, you can't say, well, there are lots of universes, and out of that particular one, which we happen to be in, that number was that thing. Well, no, it doesn't explain it.
Right.
You don't get anywhere close to that number.
Right. What is the implication then in terms of the generation of such incredible precision? Can the argument of multiple universes achieve that?
Well, I don't think any of these are going to. You see, it's such an improbable. We're talking about how special the Big Bang was.
Yes.
Now, you could imagine other Big Bangs which weren't so special. But, I mean, you can have other Big Bangs not so special, but that's not what we've got. You see?
And we're here in this one.
We're here in this one. We could have been here equally well in zillions of the other ones, you see, which weren't so special. You could have a universe which is special in our neighborhood. Our galaxy could be just as it is, but the distant universe would be different and not special out there. And that's much more likely. If you're just talking about probabilities, all these other alternatives are far more likely than the one we see. It's just, all I'm saying is that the anthropic argument, which is saying we're here and that's why the universe is as special as we see it, doesn't go anywhere to explaining the specialness of the Big Bang. Okay, it might have something to say about these few constants of nature, which we have trouble in explaining why they fit together in certain ways. But that's chicken feed by comparison with the special nature of the Big Bang. And the anthropic argument gets you nowhere. It's just, it gets you nowhere because we don't need the universe to be that special for us. It's not any use to us at all why the distant universe is incredibly special and why it came from a Big Bang, which is just part of the Big Bang, which is just as special as the part we came from. And you can't say, another argument, you can't say, well, okay, you could have got lots more people by having a bigger universe. That doesn't work either, because there's lots of cheaper ways of making lots more people. You make lots of universes. And it's far cheaper in the sense of improbabilities, that's to say it's far more probable, to make lots of universes with a few people in each one than to make one universe full of people. And that's just a simple way of saying it.
In a sense, this is an even deeper mystery than the anthropic people normally put out for us.
Yes, it is, yes. No, it needs a scientific explanation. It needs a good physical theory to say why the Big Bang had that nature that it did. And we have no theory which really explains that. I mean, people usually say it's quantum gravity. No quantum gravity theory I've ever seen incorporates the asymmetry in time, which is necessary to explain why the Big Bang had this special nature and not the singular states which come from black holes, collapses, and so on. There has to be something asymmetrical, because the second law of thermodynamics is asymmetrical. And any quantum gravity theory, which is going to explain why the Big Bang has this special structure, has got to have that in it. And no theory I've ever seen has that character.
The universe can be a very violent place, where galaxies routinely collide and exhausted stars explode. But it is also a place that gave birth to something absolutely extraordinary, at least here on Earth. Conscious, sentient beings.
It is, of course, a mystery as to why the universe exists in such an intelligible manner, but it suggests to me, at least, that there's a deep link between the universe, the grand scheme that's unfolding, and beings like ourselves. Somehow the universe has become self-aware. It's engineered the emergence of comprehending, thinking beings like ourselves who can come to know the universe.
Some people marvel at the fact that the universe has, over billions of years, given birth to beings who can appreciate its complexity. We can even ponder where and how we fit in.
We're all struck by the beauty and majesty of the natural world about us, the trees and the sky and the beauty of a sunset. It is awesome in its majesty. How can we make sense of it all? We need to look at the hidden subtext of nature, the mathematical relationships that underpin it, forming a sort of shadow world. Some people think of this as like a cosmic code.
Regardless of whether or not they believe in God, most scientists agree the cosmic code appears to exist.
Everything in the universe is determined by the fundamental forces of nature. The strengths of those forces are characterized by numbers called fundamental constants that are so sensitive that if they changed by just a little bit, the universe as we know it wouldn't be here. For example, if the rate of expansion of the universe right after the Big Bang had changed by 1 part in a quintillion is 1 with 18 zeros after it, the universe would continue to expand or collapse back on itself, and none of this would be possible. To illustrate just how small a number 1 part in a quintillion is, imagine all the grains of sand on this beach. In fact, imagine all the grains of sand in all the world's beaches. That number's probably somewhere around a quintillion. In this analogy, if all that sand represented the rate of expansion of the universe right after the Big Bang, how many grains of sand would I need to add or subtract to wreck the universe? Just 1 grain, 1 in a quintillion. That's how precise things had to be for us to be here.
But even though the Big Bang was perfectly calibrated, intelligent life would never have formed if matter had spread evenly across the universe.
Had it been perfectly smooth, then there wouldn't be any clumps which would gravitate and form stars and galaxies. So we needed slight irregularities in the distribution of matter in the universe. Had those irregularities been much smaller, stars and galaxies wouldn't have formed. Had they been much larger, everything would have collapsed to form black holes.
But even with the right distribution of matter throughout the universe, life would still never have formed without a complex series of processes inside stars that converted helium and hydrogen into heavier elements like carbon that form the basis of all living beings.
Some of those stars explode, providing raw material with which to form new stars, planets, and ultimately life. Had the laws of physics been a little bit different, or even if the physical constants had been a little bit different from what they really are, this process of nuclear fusion and the explosion of stars might not have been possible, and we wouldn't be here discussing it.
I don't know a single scientist who would disagree with the statement that the world is exceedingly ingenious. Not just mathematical, not just beautiful, not just elegant, but the manifestation of something truly extraordinary.
How could this extraordinary fine-tuning of the universe be anything less than unmistakable evidence of a divine creator?
Andy Albrecht is a leading cosmologist.
Hello, how are you?
He's also a renowned chocoholic.
I'll have the chocolate souffle and a latte.
Just as a perfect chocolate souffle relies on a precise mixture of ingredients baked at a specific temperature for an exact time, so our universe looks the way it does because of a precise balance between 4 fundamental forces.
The 4 forces we know and love in the world around us are gravity, electromagnetism, those you've probably heard of. Then there's also the weak force and the strong force. They're a little bit more specialized, but absolutely essential to make the world work the way it does. Gravity, in many ways, is the force we know first. We try to walk and we fall down. That's because of gravity. We carry something a little too heavy and it falls. It's because of gravity. Electromagnetism tells us how the chemistry works. When you cook something, the energy you use is ultimately electromagnetic energy. The weak force is about 1 billion times less strong than electromagnetism, and it's responsible for radioactivity. The potassium in a banana is radioactive. If the rate were too high, it could destroy us. The sun is basically a nuclear reactor. The strong forces release energy in the nuclear reactions. One of the remarkable things is when you add it all up, all these forces have to be exactly the way they are for life as we know it to exist. Change any one of them, dial the parameters, and something will go wrong. The planet will disappear, the sun will shut down, the DNA will come unraveled. Some people call it the Goldilocks paradigm, not too much, not too little, everything's just right. Oh, that's perfect.
Some physicists believe this precise calibration of forces is evidence of God. Dr. John Polkinghorne did pioneering work on the quark, a fundamental subatomic particle. He is also a Knight Commander of the British Empire, a Sir. And after a lifetime of distinguished scientific inquiry, he was inspired to follow a new line of work, as a priest.
I do indeed believe in God, yes indeed. Yes, in fact I'm an Anglican priest, so it would be rather shocking if I didn't. Those 4 fundamental forces are the portfolio of things that bring about the physical processes of the world. And a very interesting fact about the world is that those forces, in the specific strengths that they have to be very close to what we actually observe if we were to be here to observe them, because it turns out that only a world whose forces are very similar to the ones that we experience would be capable of producing carbon-based life.
John finds it difficult to imagine that the fine-tuning of our universe has happened by accident, that there is no divine hand behind it.
This fine-tuning makes it clear we don't live in any old world. We live in a very particular universe. And why is that? Why are we so lucky? Of course, religious belief offers you a very straightforward and attractive explanation.
One of the fundamental paradoxes of the universe is the universe is based on a simple number of constants, like the speed of light, the mass of a proton. But where do these numbers come from? These numbers are tuned like a radio, to be exactly those frequencies and energies which make life possible. If the nuclear force were a little bit stronger, the sun would have burnt out billions of years ago, and we wouldn't be here talking about this. If the nuclear force were a little bit weaker, the sun would never ignite it at all, and we still wouldn't be here.
Right.
Everything is just right to be tuned to allow for life. Einstein believed in another God, the God of Spinoza, the God of Leibniz, the God of order, harmony. The universe could have been random. It could have been chaotic. It could have been messy. But the universe is actually quite elegant, quite simple, and in fact is gorgeous. You can put the laws of physics as we know them on a simple sheet of paper. Amazing. Didn't have to be that way.
From galaxies and stars, down to atoms and subatomic particles, the very structure of our universe is determined by these numbers. These are the fundamental constants and quantities of the universe. Scientists have come to the shocking realization that each of these numbers has been carefully dialed to an astonishingly precise value, a value that falls within an exceedingly narrow, life-permitting range. If any one of these numbers were altered by even a hair's breadth, no physical, interactive life of any kind could exist anywhere. There'd be no stars, no life, no planets, no chemistry. Consider gravity, for example. The force of gravity is determined by the gravitational constant. If this constant varied by just 1 in 10 to the 60th parts, none of us would exist. To understand how exceedingly narrow this life-permitting range is, imagine a dial divided into 10 to the 60th increments. To get a handle on how many tiny points on the dial this is, compare it to the number of cells in your body, or the number of seconds that have ticked by since time began. If the gravitational constant had been out of tune by just one of these infinitesimally small increments, the universe would either have expanded and thinned out so rapidly that no stars could form and life couldn't exist, or it would have collapsed back on itself with the same result: no stars, no planets, and no life. Or consider the expansion rate of the universe. This is driven by the cosmological constant. A change in its value by a mere 1 part in 10 to the 120th parts would cause the universe to expand too rapidly or too slowly. In either case, the universe would again be life-prohibiting. Or another example of fine-tuning. If the mass and energy of the early universe were not evenly distributed to an incomprehensible precision of 1 part in 10 to the 10 to the 123rd, the universe would be hostile to life of any kind. The fact is, our universe permits physical, interactive life only because these, and many other numbers, have been independently and exquisitely balanced on a razor's edge. Wherever physicists look, they see examples of fine-tuning. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features that the universe has, he's hiding his head in the sand. These special features are surprising and unlikely. What is the best explanation for this astounding phenomenon? There are 3 live options. The fine-tuning of the universe is due to either physical necessity, chance, or design. Which of these options is the most plausible? According to this alternative, the universe must be life-permitting. The precise values of these constants and quantities could not be otherwise. But is this plausible? Is a life-prohibiting universe impossible? Far from it. It's not only possible, it's far more likely than a life-permitting universe. The constants and quantities are not determined by the laws of nature. There's no reason or evidence to suggest that fine-tuning is necessary. How about chance? Did we just get really lucky? No. The probabilities involved are so ridiculously remote as to put the fine-tuning well beyond the reach of chance. So, in an effort to keep this option alive, some have gone beyond empirical science and opted for a more speculative approach, known as the multiverse. They imagine a universe generator that cranks out such a vast number of universes that, odds are, life-permitting universes will eventually pop out. However, there's no scientific evidence for the existence of this multiverse. It cannot be detected, observed, measured, or proved. And the universe generator itself would require an enormous amount of fine-tuning. Furthermore, small patches of order are far more probable than big ones. So the most probable observable universe would be a small one, inhabited by a single, simple observer. But what we actually observe is the very thing that we should least expect: a vast, spectacularly complex, highly ordered universe, inhabited by billions of other observers. So even if the multiverse existed, which is a moot point, it wouldn't do anything to explain the fine-tuning. Given the implausibility of physical necessity or chance. The best explanation for why the universe is fine-tuned for life may very well be it was designed that way. A common-sense interpretation of the facts suggests that a super-intellect monkeyed with physics, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming. The heavens declare the glory of God. The skies proclaim the work of his hands. Day after day they pour forth speech. Night after night they reveal knowledge.